Hello everyone. The purpose of this video is to briefly go through one of our demonstrations for this week pertaining to the mystery projection. So with that being said, there will be a file folder provided for you, and please take note of the instructions on where to find that. And in this instance, that will be located under the projections handout zip file. So you'll need to download that and extract the files. And upon doing so, you will notice that you will see a projections handout, and inside of that, 4 different file folders, data directories essentially, and we're going to want the mystery projection. So just for the purpose of the activity, or the demonstration for the mystery projection, I'm going just to copy the entire folder over to my C drive, which I did right here. So with that, by exploring the mystery projection folder, you will see the problem or the general class activity. Sometimes when we had in-class courses, this was the activity that we worked through, and we're just demoing that here now for you. Project screenshot and a final spreadsheet here that we'll want to use. Well, let's go ahead and take a look at the problem briefly for this situation. This was a real problem that a student a number of years ago had, and it was pretty relevant. So I've kept it as a good way of showing how data may not be defined, but there's a very clear message in that we need to make sure our data is correctly defined as well as projected. So most data sets have a coordinate system or a projection. It's just that they're not defined. So I think of a data layer's definition as a blueprint that defines everything about that data layer. When that blueprint is gone, it's very difficult for anyone to do any work on that house, for instance, or to modify that house, into a new design, because you really need the blueprint or the data definition to make that possible. That's what this exercise is about. So here was the essentials. We'll keep this pretty brief here for you. And that in the folder, there is an Excel document that references Dunn Brothers Coffee. I think that's what it was there in GCS NAD 83. And there is another layer in there called shopping centers. This was from in the past, Metro Council's data finder, and I'm doubtful if this is there any longer, but that was projected in UTM NAD 83 at the time. So it was a UTM NAD 83 projection right here. So we know those things, that we have a spreadsheet and we have a shopping center shapefile that is projected in UTM, but in this case, ArcGIS or whatnot at the time didn't recognize the projection because it didn't have well, we'll talk about that, but ultimately it didn't have a definition. So with that being said, let's go ahead and take a look at our class data. We have a spreadsheet and we have a shopping center's shapefile. That's all we'll need for this. Our shopping center shapefile and our Dunn Brothers coffee shop class example. Let's go ahead and always explore our data, one of our rules. I'm just going to open this up in Excel, but we'll also do so in Pro. So the key for this one for you is to scrutinize and examine the categories here, because in the problem statement, the person was unable to bring this in successfully to get that to overlay. And there are a couple of reasons why. So I'd like for you to study this. Actually, I'd like to have you first, before you go any further, is to actually try to load this into Pro. I'll show you a little bit how to do that, but I'd like for you to try to add in your XY locations with a point file here. And let's see what happens with that. But first, I'm going to go ahead and make sure, back from my problem statement here, in this original email, the shopping center data is referenced right here, saying that it was projected in UTM. However, it wasn't recognized. And when we see that limited recognition, we know that the blueprint isn't set, and we need to set that correctly. So do not ever set a data layer's definition unless you're 100% sure that the projection is going to, or that the definition is going to match the projection. Because if you have a projection and you set it to an incorrect definition, it's going to be like setting your house up with a neighbor's blueprint that's completely different. It's not going to work. So only set that definition when you know exactly what the projection is in. And so with that, let's go ahead and take a look at this in Pro. There's also another recording that we've looked at in the past here with desktop as well, which I actually liked a little bit better, because in ArcGIS Desktop, the native map environment is clean. There's no map or anything like that. And whenever we try to add data to our Pro session, well, in Desktop, it would have done that too, to project on the fly to the latest layer added. And with these base maps, these Mercator base maps, I believe here, it's difficult to really understand that projection, the native projection, when it's brought in. So even though a layer may not have a definition, it still has values. It still is a projection, at least in our case here. So it will have coordinates. And sometimes when we zoom to the layer, because we have a base map in here already, it's difficult to get a read on what the native values are here. And yeah, I know that I think the default here is decimal degrees, but yeah, we have UTM, but sometimes it doesn't really help. So decimal degrees sort of puts us in the general area here of the metro that we can see around my mouse, but I don't really like Pro, to be honest with you, in terms of trying to decipher data definition problems. It's not, there's a lot of backdrop here with the Mercator projection that makes that challenging. But let's go ahead and first add our shopping center. So I'm starting off right at the beginning, and I saved my projection handouts to my C drive. Here it is right here. I'm going to see if we can map that out here. Mystery projection, and we're going to go right in here to shopping centers, and we'll try to add that in. Okay, and so right off the bat, it says up on the top up here, unknown coordinate system. And when we're seeing that, we pretty much know that, I mean, we can look at, some of the call outs here, but we know right offhand that something's wrong with this, and it's usually the defined projection tool is what we need to do. However, in this case, the only evidence we really have to make that determination is that we know that the metadata said it was projected in UTM, and this would have been in NAD83 at the time. It doesn't say it here, but it was UTM NAD83. And so with that, we know that what we'll need to do for this, even if we zoom to layer, puts us way over here in Spain, and we know that that's not really correct. So this isn't right. So the definition's missing. So with that, let's go ahead and go into our toolboxes. I'm sorry, our geoprocessing toolboxes. That's what we're after. And let's go ahead and set this definition for our shopping centers, because we know it's shopping center data if we explored our data on our attributes here. Oh, okay. Let's pin that. There we go. Okay, let's pull this up here so you can see what we have. So we have the shopping center data, and we know that a lot of this is in the Minneapolis or Minnesota area there, from Edina to, well, pretty much the metro here. So we know that we're going to be working in Minnesota UTM zone 15. Zone 15 will be for the greater area of Minnesota for our UTM zone per the metadata. So I'm going to close our shopping center attributes, and let's go down to data management. Down towards the bottom here, you'll see projections and transformations. Let's open that. Now let's look at define projection. We know right now that this is already defined. And if we do go to a UTM, we will see that some of the numbers down here are, this is one of the confusing parts here from Pro to Desktop. Pros or Desktop wouldn't mislead you by projecting the stuff sort of pseudo on the fly. But usually if we change our units here, this would give us a general indication to kind of say, based on experience, okay, these points are indicative of a UTM-based value. We can also, to a degree, maybe see that in our source information. I'm not sure if that's going to give that to us here, but sometimes we can infer from these values if they're UTM numbers, but the only way to really know that is to work a lot with, for instance, UTM or state plane or geographic coordinate systems. And as a special note, geographic coordinates are not projected. They're geographic coordinates like latitude, longitude types of things, or spherical coordinates. Lat long is not a projection. That's a coordinate system. So we can get some general inferences from looking at and exploring our data here, but what we're going off of is the metadata and that definition for this layer. So do not confuse these two. Projecting is actually going to physically change the two-dimensional properties of your data. It's going to change the values of it. Where defining a projection doesn't change anything. It just physically speaking of the data. The only thing defining a projection will do will be to set the blueprint correctly. And again, do not set the blueprint unless you're sure what it needs to be, because if you have a projection, you set it to a wrong definition, again, it's not going to be a good thing. So shopping centers are our input, and our output, we know, fortunately, based on the metadata, we're dealing with the projected coordinate system. And I'm going to come down here to UTM, and then NAD83, and then zone 15, and I just happen to know, once you get familiar with some of the zones, that zone 15 is indicative of Minnesota. So we'll set that. So NAD83, which is a datum. So if somebody says, well, it's projected in NAD83, that's not really correct terminology, because the datum is a horizontal datum used to reference a projected coordinate system onto. So UTM is more of the projection, universal transverse Mercator. That's a cylindrical projection that you'll learn about here this week. Very good for preserving long slices, like a north-south band, which is symptomatic with a zone 15 type of coordinates, or projection rather. So let's run this. And don't worry too much about the terminology. You can pause this, keep it, or run it, to pause it, back it up, stop it as you need to, but it looks like this ran okay here now. And it looks like our points have moved. I'm just going to go down here to the bottom and refresh my pro session. And with any luck, this would have moved our points here now back to the metro, which is exactly where they should be. And whether it's UTM or degrees, minutes, seconds, the degrees, minutes, seconds that you're seeing down here, XY coordinates are looking good. So that is helpful. We have one of our challenges already knocked off here. So we've correctly recognized our shopping center data. And now let's go ahead and take a look at the Excel document that we looked at a little earlier. And let's see if we can add that spreadsheet in here, and we'll see what we can do with that. So I'm going to go to my done class example. I'm going to open that. We'll load our sheet 1 in here. I'm going to right click and then open. All right. So in here, and this is again the same spreadsheet that we looked at before, but out of, when we explore data, we're always looking for things to say, okay, how can I turn this into something? And fortunately, we have this lat and long column, and that was part of the problem here, was that there's a spreadsheet and they wanted to convert that to a database and convert the location. So that's kind of what we're talking about now. We have the spreadsheet, we're going to convert the location to a point file. However, that wasn't too successful. And so a couple of reasons why. So when you're looking at this, you can go to our sheet over here and right click, and we could say display XY data. And if you do that, And I encourage you to try that. Go ahead and try that. Display XY data. And type it in, use the parameters that are given. So, basically we'll have our sheet 1 and give this well, here, we'll do it here. We'll call this one, okay. I'm gonna jump over here and save this to I'll just save that. Right here, we will call this one done, try number 1. It's Dunn Brothers, try number 1. So our longitude will be that of our X field going kind of left and right, if you will, and our Y field going up and down is our latitude. Our Z is unimportant. And our coordinate system right here is GCS. This is typical latitude, longitude here, and that was also referenced right up here. However, inside of Pro, maybe I missed it too, possibly, but I haven't been able to find the GCS NAD83 version. In Pro, they give us the GCS WGS84, which is WGS84. It's a World Geodetic System survey, if you will. It's a little bit more satellite based, but essentially is going to be a lot like a North American datum, a NAD83 for those measurements for a datum. So the 84 version will be a little bit more updated, and that's fine to use somewhere. For some reason I can't seem to find that in Pro, but it should be there for those of you who have used desktop in the past. Let's go ahead and say okay. Okay, so we're seeing some warnings jump up on here, just invalid geometry, things like that. I'm going to go ahead and close my spreadsheet. And we know that something came in. Let's zoom to layer. We still don't even, who knows where that stuff went to? I don't even know. And, what is interesting about that, if we look at our attribute table, just in general, it looked like nothing seemed to really fit per our warning signs. And I wanted to come back and have you stop the recording right now as soon as you hear me out here. Before you go any further, I'd like for you to scrutinize. There's something wrong in here. There's something wrong in the spreadsheet. And I'll give you a hint. It has to deal with these 2 columns. When we were speaking of decimal degrees, latitude, longitude, when we think of decimal degrees, we are referencing the north-south line that runs through Europe. And when we're east or west of that, we're going to have some changes in here. And so take a look at your readings for this week, in particular in some of maybe the tutorials, or see what you can infer from this, why we might not be able to generate decimal degree data from our 2 columns here. So I'm going to just pause the recording. I encourage you to do the same and think about what's going on here. So if you saw me just pulling up some information, I realized I didn't hit the pause button, but that's okay. and maybe you did, but I did want to share with you some of the findings here that when you were looking at this data right here, a couple things should jump out at you. We're talking about decimal degrees, referencing the prime meridian over in kind of running north-south there over in Europe. Anything to the west of that would have a negative for our longitude. And also you might be saying to yourself, wow, these things should have decimals in here. And so what I wanted to pull up is a graphic to highlight this for you. But here we see our prime meridian, obviously north and south and east and west over here. But here we have our north. And so anything to the west of that, you're going to see these negative numbers. Now, again, this is referencing the sort of the what we call the standard quote flat map projection here, but decimal degree values that come from the lat long, more not so much the degrees, minutes, seconds, which are kind of angular units, but this is just decimal degrees, kind of that planar or the flat map, if you will. So if we're up here in the metro, we're looking at negative 90, 91, 92, whatever we are up in here for a some of our longitude values and our latitude. Here you can see we have 30. We're obviously north of the equator. Here we're 30. We're not up to 60, but I think we're somewhere around 44, right up in here, 45. So that should be telling you some really good clues when you look at the spreadsheet. Our longitude should all have negatives, and all these should have 2 decimal points in, like 45 point something. This would be negative 93 point something. So all of this data was set up incorrectly. This is it's not that it's incorrect, it's just improperly formatted. So when we're scrutinizing data, we need to be looking for little clues like that that do not make sense, that might make more sense to us if we look a little bit more closely here. So with that, what I ended up doing was providing another example out there for you that had what's called done class example negatives. And what that spreadsheet has in here now is would be all the values with the appropriate formatting. So this is just an example of standardizing the data, making sure that the input data is correct, because somebody that just would have taken the regular values, like this, and tried to generate data from it, they said, well, it has lat long, why is it giving me any data? We have to be thinking carefully about that just looking at these, like if we're talking about the metro, and this is just comes through experience of working with data, that gosh, we could be dealing with decimal degree values right here. So we need to be looking and thinking about that. So lo and behold, here we go. So let's try this in our our session here. So I'm going to remove done try 1. And let's go ahead and I'm going to remove the sheet 1 here as well. Let's go under add data again. And I'm going to come back here to class data. Let's back up one more. And let's open up this done class example under bar negatives. And let's load sheet 1 in there. Okay, explore the data. Let's open that up. And here we see everything. This looks perfect. So we have our longitude and our latitude all properly assigned. Now what we can do, let's right click on our sheet and let's say display XY data. Okay. We'll give this one we'll call this one done final. Dunn Brothers Coffee Shop, final locations. Our defaults are lat, long, X is our long, latitudes are Y, coordinate system, GCS, WGS84. Again, that's going to be okay. We know that we're in GCS, degrees, minutes, seconds, geographic coordinates, but with the WGS datum 1984, let's go ahead and run that. Our Z field, we do not need. Z field will reference vertical notations in our data. But now if we zoom in here, we can obviously see our little symbols here. And so you can modify those as you wish. But now we have our data at least all into, it's not all projected now into that of latitude or inside of UTM NAD83 zone 15, but we're seeing a lot of project on the fly happening. And project on the fly can happen when we have successfully and correctly made the appropriate data definitions for all of our data. In other words, when the blueprint matches the data, we can project on the fly because the software can interpret and read those definitions, those blueprints, if you will, and adjust them on the fly to match. But now, to have a little fun, we know that our shopping data is correctly referenced or projected in UTM NAD83 zone 15. Let's go ahead and project our Dunn Brothers final into that. So we could check this by inserting a new map. And let's go ahead and drop in here that of our Dunn Brothers final. Let's see here, where did we save that? Okay, let me come back over here. Let's see where I saved that to, I don't remember. Class data, done final. Okay. Come over here to map 1. Try a refresh. Well, maybe I misplaced this somewhere here. I'm going to pause this and let me check that out. Well, I can't seem to find my data here, but that's okay. We're going to go ahead and let's make sure this is all, like right now and this is what's confusing about project on the fly, folks. You know, when we're talking about, yes, we're representing our data here in decimal degrees, but we're kind of giving the false impression that everything is projected in decimal degrees. And it's not always the case because we know our shopping centers, that's projected in a UTM coordinate system. So it's not latitude, longitude, or decimal degrees here. I mean, we could, yes, sort of change on the fly the units of measurement, but that's what's always really confusing about project on the fly. Like we never really know what our data's in. That's why I do value a little bit the old desktop, because it didn't have all these things happen. Like the more choices we have to display our data, the more it can complicate troubleshooting, I guess is what I'm trying to say. So I'm not a huge fan of that in Pro, to be honest. But now let's go ahead and we're going to project our done final out of here. Notice I selected my different tool here, my project tool. So we're going to drop in here done final, and that's our input coordinate system, GCS. Output data set, let's save this where my other data was supposed to be going, and we're going to call this one done UTM NAD83. All right, coordinate system. We're going to physically project this out into a UTM NAD83 zone 15. Okay. All right, and a small transformation occurs. Basically what that's doing is it's transforming from one datum to another, just updating really some horizontal numbers, if you will. Okay, so that should be good. Now I'm just going to actually remove all of these. I'm going to remove my first map. So we're dealing with just clean. So there's just nothing. I'm going to insert a new map. When in doubt, I always like to start a new map and work with that. So to add data in here, let's go see if we can find our data sets again. And here we are. So I'm going to load in my shopping centers, which I know for sure that that is in a UTM. And the nice thing about that is we're seeing the numbers change. Did you see that down here at the bottom? The first layer that you add into your session will default to that coordinate system. Before, it didn't do that in our prior map because we never had a data definition for the shopping centers until we had, maybe brought in, or we zoomed a layer on, once we set our definition and zoomed in a layer, but then we still were in decimal degrees, I think from the Dunn Brothers GCS setting. So it's really confusing. When in doubt, add a new map. Go up here, insert a new map here, and then drop in a layer when it's defined. And if it's defined correctly, it's going to line up where it needs to be. That's the whole point of this, to show you. Now we know that we are in here. These are really good numbers to look at. Like I was showing you in the extent before of that shopping center data. Before we defined it, we looked at the spatial extent in our metadata, and it gave us some of these values right here. And these are classic examples of UTM-based values for XY location. So that's what tells us, gives us some clues that it might be a UTM projection. But again, you're only going to know this when you start practicing with data in UTM or whatever it is, to get familiar with what those should be. That's the crux to learning projections, is trying to figure them out in that manner. I'm going to insert another new map up here. That's just clean. There's no default items in here. And I'm going to add in here now, not my shopping centers, but my Dunn UTM. And that also should have a UTM-based measurement, which it does right here. That makes me happy, because if it wasn't true, if it didn't have a UTM, number one, it wouldn't be here, or it'd be somewhere a long ways away, or these numbers wouldn't be the same as our shopping centers. So now if I add my shopping centers in here as well, they all will drop right in here on each other. And we know that both of them now are correctly projected in a UTM, NAD 83 zone 15. I'll try that here just to show you. If we go under insert new map, to show you that we can still project on the fly, I'm going to add in here our done final. So this would have been the decimal degree version. So like the -93 and +44. So this should change right here. So your values change on here at the bottom of your screen. This tells us now that, yeah, the data is represented in decimal degrees, but also under properties that should be preserved under a spatial reference as well. So it tells us geographic coordinate system, WGS84 datum. But because we've successfully defined our shopping center as a UTM, the software will be able to interpret that blueprint, project it on the fly to match, which is just what we're seeing here right now. So the moral of the story is know your definition, your data definition. If you're not sure what it is, do your best to figure out the coordinate system that the data is in. And number 3, never be fooled by project on the fly, because it could give you some false indications of what your data layers actually are projected in, when in fact they are not. All they're doing is referencing the project on the fly functionality that's embedded within the software that you are using. So there you go. That's a little bit on the that's a little bit on the mystery projection. Hope this was helpful. If you have any questions, please feel free to reach out. Have a good week.